In this video we're going to look at how we plot a linear graph. So what that means is getting our information from algebraic form here into a straight line graph over here. Now what we need to do is find a graph where every point on the graph, the y value is going to be whatever x value you choose plus 3. That's the rule we're going to use. So first of all, let's finish drawing up our axis. So we need to put an arrow on this end. There's our x-axis. Here is our y-axis. And remember, we have all the positive x values along here. Our negative x values here. Our y values are positive up this way. And negative down this way. Don't forget to put the negatives on. Okay. So what I want are points on this axis where the y value is just 3 more than the x value. So if I start, let's say, with x equals 1, if x equals 1, then my rule here is telling me that the y value is just the x value plus 3. So the y value is my x value that I chose plus 3, so my y value is 4. So I need to put on the point x equals 1, y equals 4. X equals 1, y equals 4 up here. I need 2 points to be able to draw up my line, so let's choose another point. If random, just choose any number I like. Let's choose x equals 5. If x equals 5, then the y value is the x value plus 3. 5 plus 3 is 8. So I need to put on 5, 8 onto my graph. So x equals 5 is here. Y equals 8. I only went up to 5. Let's go 6, 7, 8 up to there. So 5 on the x, 8 on the y is here. I could choose any other value I like too. Let's put one over here. If x is minus 4 and the y value is minus 4 plus 3, which is minus 1, so my coordinate is minus 4 on the x, minus 1 on the y, which is minus 4 on the x, minus 1 on the y here. I could keep going and getting any number of points I like, but the fact's going to remain that no matter how many points I put on, they're all going to be on this line that's joining all of these points here. It's going to keep going in this direction. It's going to keep going in this direction as well. Let's keep it going down here. And any point on this line is a point where the y value is 3 more than the x value. So let's check it. Let's just choose any number we like. X equals 3. Is the y value 3 more than the x? Yes, it is. It's 6. Let's choose minus 1. Is the y value 3 more than it? Yes, it is. 2. Any point on this line, the y value here is 3 more than the x value. And that's what the line is showing us here. In order to get our graph onto the axes, we need to just have some random points put on, and I just randomly chose these 3. You can choose any numbers you like, but sometimes when you're doing an exercise, it'll actually ask you to plot particular points, and it will be presented to you in a table of values. So it might look something like this. Where they give you particular x values. Now they're nothing special, they've just been randomly chosen, but it's just saying if x is minus 2, and this is the equation we have to graph, come up with our y values and put them on the axes. So the first thing we need to do is just choose the first x value. So that's saying that x is minus 2. Using our rule, the y value is 2 times the x value we've chosen, minus 4. Now 2 times minus 2 is minus 4. Take away another 4, we get minus 8. So minus 8 goes in here. If x is minus 1, and the rule says that the y value is 2 times the x value, which is minus 1, take 4. 2 times minus 1 is minus 2. Take away 4, minus 6. So I have minus 6 on here. And we keep going. 2 lots of 0, well that's 0. Take away the 4, minus 4. 2 lots of 1 is 2. Take away the 4, I'm at minus 2. 2 lots of 2 is 4. Take away 4, I get 0. I could keep going, but these are going to be enough points for me to put on. So let's have a look. Minus 2, minus 8. Minus 2 on the x, minus 8 on the y. Minus 2 on the x, minus 8. Once again, I didn't go far enough. Let's just quickly put those on. So minus 2 on the x, minus 8 on the y is there. My next point, minus 1 on the x, minus 6 on the y is there. 0 on the x, minus 4 on the y here. 1 on the x, minus 2 on the y. 1 on the x, minus 2 on the y. And you can see that our dots are making a straight line. I haven't even finished putting all the points on yet, but I can see what my graph is going to look like. Let's put our last one on. 2 on the x, 0 on the y is here. Next thing I need is just grab my ruler, and we should be good to join these up. So let's go like this. And just because I stopped here, it doesn't mean the line stops here. It keeps going in either direction. Let me just extend this. It's going to keep going in either direction, and just extend it as far as you can for your graph. Putting on all of those points that you've worked out, and then extend your line as far as you can. And this red line just represents all the points where the y value is 2 times the x value, take away 4. Anywhere on this line, it represents that. So if I wanted to know what the value of y was when x equals 4, now I haven't got that. I haven't found that in my table, but if I wanted to know what's going on at x equals 4 on this red graph, here's x equals 4, I could just transfer up until I hit the line, go back across. I know at x equals 4, y also equals 4. If I want to know what's happening at x equals 3, here's x equals 3, let's transfer it up, head across until we get to our y. We know that y equals 2. What about if I wanted to know what the x value was if y equaled, let's say, 6? At y equals 6 here, we could transfer it across until we hit the axis, and then head back down. At y equals 6, I know that x equals 5. So I can use my graph once I've got it to get my different x and y values without having to do all of the algebra like we did over here. Every linear graph, as you draw them, you'll see that there's certain features of the graph. We talk about the slope of the graph, how steep the line is, and looking back over here at these two, the purple line and the red line, if we compare them, you can see that the red line is steeper than the purple line. So I should say red is steeper than the purple line. See how we're going up faster than we are there. So we talk about the steepness of the line, or another word for steepness is the same as gradient, which is just a fancy maths name for steepness. If our line is sloping in this direction, we say that we have a positive steepness or positive gradient. If my line was sloping back over like this somehow, I would say I have a negative gradient. If my line's just going straight ahead, it has a zero gradient or zero steepness because it's very flat. And if my line is going straight up and down in a vertical, we can't actually talk about the gradient. We say it's undefined. It actually doesn't have a gradient at all. The other features that we need to be aware of on our linear graph is where it cuts the axis. So where does it cut the x-axis? And we call that the x-intercept. Where does our line cut the x-axis? And you can see here, this cuts the x-axis when x is -4, and the y value, remember the y value tells us how far up and down to go. It's at 0 because we haven't moved up or down. The other point we need is where the graph cuts the y-axis. That's there. That's our y-intercept. Now the y-intercept as a coordinate, we know the y value is 3, which is the second number we put in. The x value, keeping in mind that the x is how far across we've gone, we haven't gone across at all, we're actually on the axis, so our x value is 3. So again, the things we need to talk about, the features, are the steepness or the gradient, the x-intercept, and the y-intercept are the three things that you'll be asked about when you're talking about a linear graph, because they're the things that tell one graph apart from the other.